This is Brian Smith with Physics Section M, Lab Section M06, and this is my Test 2 problem that I've redone for YouTube. I chose problem number 3, which says there's a glass sphere of mass m and charge positive q. The sphere is hanging from a spring at angle theta from the vertical. A distance d away, another identical sphere and spring are also hanging at the same angle from the vertical. First part has me choose the sphere. The left sphere is your system, and list the objects in the surroundings that are interacting with my system. Here we have the provided graph. I went ahead and labeled different parts. This is sphere 1, this is sphere 2, spring B, spring A. And as you can see, both these are theta. Here's the separation D, and I chose my system as sphere 1. The surroundings on sphere 1 are the Earth, spring A, and sphere 2. I drew a force graph here to determine these surroundings, and it's everything that is acting on the sphere 1. Obviously we have the force due to electricity, or not electricity, but the electric force. We have force due to spring and force due to gravity. Part B is to determine the magnitude of the force of the spring on the left sphere. Well, the force of gravity is negative mg in the y, newtons. Force of the electric force is in the negative x direction, so you've got a negative 1 here, and it's 1 over 4 pi epsilon naught times q squared, and it's really charge 1 times charge 2, but they both have the same charge, so it's q squared, and the separation r squared, the magnitude of the separation, but we already have this magnitude, which is d, so it's d squared. And 0 in the y direction, 0 in the z direction. Then we have the force due to spring, which is a combination of these two forces. It's supposed to cancel out these two forces, so you flip the sign on each of these forces and plug them in. There's no force in the z direction, so this also has no force in the z direction. To find the magnitude of the vector, you just do x squared plus y squared plus z squared under square root. So here you have square root of 1 over 4 pi epsilon naught times q squared over d squared, all that squared, plus mg squared plus 0. That gives you the force of the spring magnitude is the square root of 1 over 4 pi epsilon naught squared times q to the 4th over d to the 4th plus m squared g squared newtons. This was the part that I got wrong on the test. Somehow I managed to forget to use the electric force in my calculations. I don't know why that was worth 12 points, but there you go. Moving on to part C, we're supposed to calculate the angle theta in terms of the other variables given in the problem and physical constants. Well, first I rewrote the force graph here, and I noticed, using just basic trig, that this angle here is going to be the same as the given angle here by this graph over here with similar angles. Using that, just taking from the previous part, the force of the spring is xyz, with x being this, y being this, and z being 0. In order to find y, if you have the magnitude of the force of the spring, is multiply it by the cosine of the angle, and that equals y. And that's from back up here again. This angle here to the y-axis, the magnitude times cosine of the angle to the y-axis is equal to the y component. So rearranging, you've got cosine of the angle equals the y component over the magnitude of the force of the spring. Using arc cosine, you can find the angle is equal to the arc cosine of the y over the magnitude of the force of the spring. That leads us to our final answer here, which says that theta is equal to arc cosine mg over the magnitude of the force of the spring, where the magnitude of the force of the spring is, again, the square root of 1 over 4 pi epsilon naught squared times q to the fourth over d to the fourth plus m squared g squared. That's all for this question. And this is Brian Smith for Physics 2211 at Georgia Tech, Section M, Lab Section M06.